Okay, so in the previous video, we talked about standard deviation, introduced the idea of it, and talked about how to compute it as the square root of variance. And we talked about it as the standard deviation of population. Okay, and it's when we're talking about the whole population, we can compute standard deviation really straightforwardly and directly like that. However, if we're doing it for a sample, then the computation changes just a little bit. And I don't want to get into the algebra of why that's the case, but there's good reasoning for why this is true. But when we have a sample of the group, we can't do the same computation. We have to change it just a little bit. Specifically, we're going to just subtract 1 from the number of subjects in the sample. So rather than divide by the number of subjects in the sample, we'll divide by 1 less than it. Ultimately, it's just a matter of it's more accurate in the long run when we do it this way, but I don't want to get into all of the history of why that formula is the way it is. So if you're doing it for a sample, we'll take 1 less than the sample size rather than the actual sample size. And the standard deviation for a sample is denoted with a lowercase s. That is the English letter S, not a Greek letter, the lowercase s. And typically you'll see an X in the subscript representing the data that's being measured here. So let's go ahead and find standard deviation for a sample. It's going to be all the same computations as we have done in the previous examples, but instead of dividing by n, we divide by n minus 1. Suppose we had a selection of 10 Cascade students who were chosen at random to report the number of hours of TV they watch in a week. The data is as follows. And we want to determine the standard deviation of the data. So 10 students is obviously not the population of Cascade students. It's clearly a sample. So we're going to be using our sample formula. But the process is going to work the same as it has for all the other problems that we've been doing. Let's see, if we look carefully, none of the values repeat, so we don't need a frequency column. But here's all of our scores are going to go into one column. We'll want the deviations in the next column. And then we'll want to square the deviations in the next column. And then we'll be able to use the sum of those squares of deviations to find the variance. So I'm going to pause and fill in the first couple columns real quick. Okay, so I've filled in the first couple columns here. Here's all of the different values for the number of hours of TV the students watched. I also computed the average. The average is 8. So a typical student at Cascade, or in this sample, watched about 8 hours of TV each week. So then we can compute the deviations. This person who watched 2 is 6 hours below the average, etc., all the way down. Now we just need to square those deviations. And what we want to do is take the sum. Variance is going to be the sum of all these divided by the number of values that are in there. So we have, let's see, if we sum all of these together, we would get, let's pause real quick. 182 is our sum there. When we add the squares of all these deviations, we get a total of 182. We know variance is that sum divided by the size of the group. But because we know that we're talking about a sample in this case, when we do a sample, we divide by 1 less than the size of the group. So variance is 182 over 9, which is going to be 20.2 repeating. So there's our variance. We're asked to find standard deviation. Remember, we just said standard deviation is represented with lowercase s sub x. So standard deviation is equal to our variance, but we're going to take the square root of it. So the square root of 20.2 comes out to be 4.5, which means our standard deviation is 4.5 hours. Okay. We saw earlier that the typical student watches about 8 hours of TV per week. But we also see now that the typical student is about 4.5 hours away from the average. So we could say the typical student at Cascade, or at least in the sample, watches about, their average number of hours per week is about 4.5 hours away from the mean. Okay, and in fact, nobody in the group watched 8 hours, so everybody was some distance away from the mean, and typically they were about 4.5 hours away from the mean. So there's interpreting standard deviation, there's understanding how to compute standard deviation, and notice that it's a slightly different formula when we do standard deviation and variance for a sample versus a population.